Hey guys, this is Sunit Jindal. I am part of Nykaa's engineering team, and today I am here to present our journey of making a performance site. Our journey started in the year 2019 in the month of April. At that time, our site was pretty slow. There were many factors which were making it so slow. Like Saurabh's talk was bang on. It explained every issue we had. His presentation of option A and B correctly presented our story. Our site wasn't rendering content soon enough, neither it was interactive. One of the major issues that was making this site slow was our two large JavaScript bundles, which amounted to 709 KB. If you uncompress that data, that's almost 3.5 MB. Every week, we kept on increasing some fixes to improve our FCP, SMP, and various other data. After a few months, we were able to achieve a score of 36. This is a score that we achieved after almost 4 months. There were many issues that we faced while making these improvements. After reaching a score of 36, we realized there's something that we need to do and change how we are improving the performance of our site because the rate of improvement wasn't enough. So before re-executing or restarting this execution phase of improving performance of site, we wrote down what we learned by doing these improvements. The first one was to understand the difference between first party and third party scripts. You might be focused on your first party code, whereas your third party code might be dragging you down. So when you are improving performance of your site, pay attention to third party scripts as well. Compression. So compression is used by almost every site. But the question is, are you using the right compression level? Are you using the right compression algorithm? For example, while investigating the issues with our site, we came across multiple articles which clearly stated if you want to compress your static assets, use Broccoli. Broccoli gives you around 15% better compression ratio for your JavaScript and up to 20% better compression for your CSS files. Even if you are using gzip, do check what level of compression you are using. gzip provides you compression levels from 1 to 9. 6 is the default compression level that comes default enabled. I'll recommend to use at least 8. Same goes with Broccoli. Broccoli comes with compression levels from 1 to 11, and 1 being the least compressed and 11 being the most compressed. Effective CDN. Now, if you are not using CDN, I'll strongly recommend that you start using one. When you're shipping your content to the users, your users might be sitting across various geolocations. These edge servers help you deliver your content faster to your customers. Once we had all the information what we learned, what we were doing wrong, we decided before we enter the execution phase, we'll write down exact goals what we wanted to achieve. During the first phase, the major challenge that we faced was that no matter how much improvement we did, our initial render times were still pretty bad. They were always about 3 seconds. We wanted to reduce it to less than 2 seconds, avoiding render blocking CSS or content can really improve performance, initial rendering performance of your site. So just don't focus on JavaScript. CSS is also as critical as JavaScript. Managing third-party scripts. While a lot of time third-party scripts are very important, developers do not give them enough emphasis. If you're loading your third-party scripts at the early stage, then your network can choke and even your main thread can also be choked with so many files. Using optimal bundle size and DOM nodes. In my first slide, I showed what a big bundle we were using. Never do that. Try to break your bundle into smaller chunks so that files can be loaded lazily or as per requirement on the page. Same goes for DOM nodes. If you have too many DOM nodes and the depth of DOM nodes is also high, it becomes expensive for browser to render content. If you reduce number of DOM nodes and optimize the depth, the content can be painted sooner on the page. And last but not least, we aim to achieve a score of more than 90 in Lighthouse. So this was an easy target, but we said if we want to achieve something, let's go for this. Now, there was another step that we took because we already tried to improve performance of our site. We encountered many challenges. One of those challenges were how do you measure or quantify what you have done is actually impacting or making a change in terms of your user. Using one tool might not provide you enough data. Same thing was explained by Saurabh in the previous presentation. So performance monitoring can be broadly divided into two categories. One is synthetic monitoring, where you perform all your tests in a lab. You define the subject as well as the environment variables. Subject in our case is going to be a web page, whereas environment variables are going to be the CPU power or network bandwidth. So tools are same like Lighthouse, which gives you insights of whether your site is compatible with PWA, how it is, what's your score in terms of accessibility, in terms of performance. It also gives you best practices guidelines, and it is destined to hurt your feelings. The next tool is PageSpeed Insight. Again, it uses Lighthouse and also provides you field data from Chrome User Experience Report. By using this field data and comparing it with the lab data, you're able to get real picture of performance of the site. And third, but not the least, it's web-based test. Web-based tests allow you to perform tests across multiple geolocations. Even this is the greatest point about web-based test. At certain geolocations, you can perform tests on real devices. Also, you can create comparison of your various tests, which gives you a great idea of your improvements across your journey. And then comes the second category is real user monitoring. This is the data that is collected from real users. Though there are many real user monitoring tools, our favorite is SpeedCurve, which provides you many meaningful insights and help you debug a lot of issues. Other than that, SpeedCurve also provides you a facility to perform synthetic monitoring and applying budgets on your performance. But a lot of these tools are paid. If you are trying to go for a tool that is budget friendly, I'll recommend to go with Firebase. That is a tool provided by Google. It's free of cost, but there's a lag of 1 day in the data. And third, which Saurabh has already explained, you can use Crux field data. Crux field data gives you many meaningful insight, and we use it even today. Key gotchas. These points that I'm going to discuss, these points are what you should be extra cautious while working on performance of your site. Understand your customers. Your customers are most probably spread across multiple geolocations, will be using different devices, will be using different network service providers. Now you may ask how a user using different device would impact performance. Just think about it. An iPhone would have far higher computation power as compared to a medium range or low end device. And as per network service providers, different service providers have different latencies, and those latencies vary when you travel from one city to other. Efficient loading of assets. Now, you might be able to optimize your code. You might be able to reduce your CSS. You might be able to reduce what all content you are shipping on your page. But if your network graph looks like this, there's something that needs to be fixed. Try to free up your network bandwidth. By freeing up your network bandwidth, you'll ensure that your page is interactive even on low end and devices which have poor connection. If your network connection looks like this means you're loading your critical content first, loading, and you have prioritized what content you are loading on the page. You can load a lot of content after a user interaction. For example, you should split your code into you split your pages into above the fold and below the fold content, and you can do with below the fold content. You can further split that section in two or three more sections depending on the need. And the results. So now I'm going to talk about the results that we were able to achieve post these migrations and considering all these key points that I discussed. The first test which we executed on our PD page was this. We were able to achieve a score of 92. If I compare this score with our previous score, we were able to reduce our time to interactivity by 72%. Again, this test was executed on fast 3G network. Our speed index was improved by 81%, our FMP and FCP were also improved by 56%, and our first CPU idle occurred 69% sooner. Now let's talk about we discussed about that our score improved, but what changed? So this is a screenshot of our network. Before making those improvements, our HTML size amounted to 182 KB uncompressed, and we were downloading 5.2 MB of data again uncompressed. Post migration, we were able to reduce the size of our page to 102 KB. This was mainly because the amount, not just HTML that we were shipping, our stack is React based, so and we do server side rendering, so we have to send JSON as well to rehydrate our UI on the client. We optimized how much data we are sending in that JSON. Other than this, we were able to reduce the total data that is needed on the page from 5.2 MB to 2.9 MB. There is one more critical thing that I would like to tell you about this thing. If you look at the bottom left corner, their total number of requests on this page were 165. Post migration, we were able to reduce the number of requests to 58. This also helped us achieve a better performance for our users. As I told you, synthetic monitoring and real user monitoring both are critical. We did real user data collection as well. So one thing that you should observe is in our synthetic test, lab test, our first initial render was at 1.1 second, whereas in RAM data it's 0.6 second, which makes sense because at least in India, since Jio arrived, 4G adoption has skyrocketed and people are using better device than Moto G4. Now, a little comparison of our RAM data from post-migration, pre-migration. We were able to reduce our first contentful page by 64%. DOM content loaded was reduced by 84%, and page load times were reduced by 82%. Now let's discuss key factors which helped us in achieve all these improvements. Of all those learnings, key gotchas lead to these final points. HTTP2. HTTP2 provides you multiple benefits from multiplexing, server push. There are many benefits of HTTP2, but the most commonly used, which you can use even today out of the box without doing any change, is multiplexing. Multiplexing allows downloading of multiple sources through same connection, which means downloading resources is cheaper in terms of your CPU power as well as network bandwidth. Since you do not have to create new connection for every file. Lighter JavaScript libraries. So post migration, we were able to reduce 2.7 MB of JavaScript. Partially it was from third-party scripts, partially it was from our JavaScript libraries, and a lot of it was from CSS as well. For our JavaScript libraries, we chose lighter alternatives. For example, in place of React Slick, which is a great library and we have used it for years, we chose React Swipeable. So React Slick provides you many options, which were not really needed for our site. Whereas React Swipeable is a simple, unopinionated library which provides you very basic functionality upon which we created our custom carousels. We did this with many other libraries. Along with this, we also removed all third-party CSS frameworks or libraries, and we went with our own CSS. Removing those bulky CSS frameworks helped us reduce render blocking content. Optimizing front-end service. Now, if you really want to improve performance of your site, it's not just about reducing the size. It's not just about reducing JavaScript bytes or reducing CSS bytes. It's also about how soon you can deliver your content to the customers. For example, we discussed about CDN. Same applies to your server. If you're rendering your content from server, which we are doing for all our main pages, and you are able to reduce even 50-60 millisecond of time by optimizing your servers, that's a big win. For our servers, we were able to reduce 66% memory usage for these servers, and also time to first bytes were also improved. Code split. Now, not every content or every code is needed on the client browser when they first open your site. For example, if a user come in on your PD page and your reviews or your recommendations are in below the fold content, the question is, should you load that content while user just open your page? The answer is no. Try to load critical content with which user can interact sooner, and load additional data when your network bandwidth becomes free or when user interacts. For example, if user starts scrolling. Critical CSS. Again, this is one of the major major factor that's going to impact your initial render time. When the browser encounters any CSS file that needs to be downloaded, browser pauses any re-rendering or repainting until that file has been downloaded, parsed, and CSS home is prepared. It might happen once CSS home is prepared, you might start downloading fonts which were not configured properly, which might further delay re-rendering on the page. To solve this problem, we used CSS in JS libraries which provide shipping critical CSS out of the box. In our case, we used emotion CSS. To give you some numbers, before this migration on our page, we had more than 90% of unused CSS. Post this migration, the percentage of unused CSS was just 3 to 4%, which is a big improvement. And right now we have zero render blocking calls on our web pages. Managing third-party scripts, like this is the third time I'm referring third-party scripts. It's not like third-party scripts are evil or something. It's just they can really uh, bring you down. So third-party scripts are very critical for your business. Third-party scripts, via third-party scripts, you measure performance of your site in terms of analytics. You use those scripts for remarketing, which is very critical for e-commerce businesses. So what can we do to manage these third-party scripts? Your modern day browsers come with some great APIs that you should use. Request idle callback is one of those. Request idle callback is triggered when your main thread is free, so you can choose to load your third-party script once your first party code has been downloaded and passed. This ensures that user is able to interact with your page sooner. Other than this, browsers also provide you capability to check which connection user is currently using. If user is on a 2G network, probably you shouldn't even load third-party scripts, because if you try to load those scripts, they might not even get downloaded and the page might be unusable for a user. In case of 3G networks or 4G network, you can decide how you want to manage your third-party scripts. Performance budgets. So from starting of this presentation, we discussed that how we made our site, improve performance of our site. Now, improving performance of your site is only half your journey. Rest of the journey is maintaining it. Performance budgets ensures that any regressions that happens in terms of performance are identified at earlier stage. For example, in our case, when we released these new pages on the production, within 2 weeks, our scores went down from 90 to lower 60s. And like we went bonkers, like we just fixed everything. How could this be so bad? And the issue was that one developer added an async, forgot to add async property to a third party script. So these performance budgets would really save your life. And last but not least, we invested heavily on continuous integration. Now, any PR that comes for merging or any feature that we develop is not merged into our master until certain continuous integration checks are cleared. Those checks includes bundle sizes. After development of any feature, your bundle size shouldn't rise beyond certain size. Your lintings and even lighthouse scopes. And in the end, I would like to show you a video which again these tests were performed on 4G network. On the left side is our new page and on the right side is our old page. So as my closing remarks, performance optimization is not a destination, it's a journey. So it's something that you will have to keep doing, and we are still doing it. Thanks a lot.